Hello, everybody. My name is Luis Felipe Zapata Rivera. I'm from Medellin, Colombia, and I'm presenting Smart Adaptive Remote Laboratories. In this case, this video it's a short tour around some demonstrations we have implemented to show the power of online labs. So, as you can see in the screen, we have developed a system that allow users to log in and perform laboratory experiments from home or from every place using different devices. So I'm going to start with some examples of labs that we have implemented. Starting, for example, with this lab one, where we have a railroad crossing system that can be used for different experiments. So the experiment is located in the right side of the screen and the activity in the left side. So you can, in this case, we ask the student to implement a code to blink the LED, as you can see in the screen. Every action of the students is recorded and it's sent to the professor. We have here a sample of the reports we generate and how these activities are tracked. In this case, we can see that a user uh, perform an activity. The user that you can see here uh, perform an activity over a lab experiment. Going back to the system, we can access another laboratory that is about colors. So in this case, we implemented a very low cost lab that is in the university. And what are you seeing in the right side? It's a video streaming. So we can interact with the lab experiment with the buttons and the controllers that are available for this lab. And there is an activity where the student has to use their lab kits to perform some sequence of colors in the screen in the remote lab. This also is used, for example, for teaching number conversions. So the system generates a color, and that color in this case is red. So the student has to enter the binary number of the color red in RGB combination of 3 bits and the decimal value. Continue with the experiments. We have a version of that color matching generator lab with Blockly. So in this case, we have a code that is constructed using Blockly from Google, and we have developed the conversion of the code to be executed by the remote lab. So once the student implements the code, they can see the Python version of that code and they can save it in the remote lab and execute it. So as you can see, that code performs some sequence of colors. All right, so let's now with that we saw the ability of those labs to be implemented with different activities and different interfaces. We call that smart adaptive remote labs. So we have a third experiment that is a basketball station. It's a tabletop game which is very inexpensive, and we adapted with servo motors and sensors. The idea here is that the student have also to implement something either in the Python code console or in the remote kit, laboratory kit they have at home. So once the students complete the task, they save it and they can run it. When they run it, the station will execute the number of shots that the student program in their code. You can see in the right side of the screen the basketball game playing. The system is going to calculate the score, in this case 0, and is going to send also the report to the professor. Finally, we have two more experiments. One is a railroad crossing system that we saw at the beginning, the first activity of blinking the LED, but now for the use of simulating a railroad crossing system. So in this case, the student has to implement the code to close the gate and blink the LEDs for a couple of seconds and later raise the gate up again. So when the student accomplishes this, he can move to the next task, that is the simulation of the same railroad cross system but with a real train in the back. So as you can see in here, there is a real train crossing the background of the experiment. So now the student has to count with the timing of the train coming from left to right or from right to left. This is a mix of virtual elements and real elements. Finally, we have an experiment that is based on to control a robot, and they can control it from the left side, and they can walk through the field that he has there, and he can shot to capture some elements in the scene. In the future work, we are going to replace what is white in the walls for some virtual elements that are things that the robot has to collect and bring to and have some specific mission. So that's it. This is a quick overview about what we have implemented during the last couple of years in remote labs. And thank you for watching.